Alright guys, here is the last conic that I have notes on for you. We're going to talk about hyperbolas. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points, called the foci, is constant. So if you compare this to the definition of ellipse, the only word that's changed is instead of the sum of whose distances, it says the difference of whose differences. So a lot of how we're going to graph this is going to be similar today to what we're doing in ellipse. It's just how we draw it is different. So just a couple terms we need to talk about. Let's talk about the term vertices first. The vertices are going to always be right here. It's kind of like that turning point on the hyperbola. They also happen to always be on the imaginary line that would go through the foci, which is called the transverse axis. So I'm going to draw that in. This would be your transverse axis. The vertices always go on that line. And then the center is the midpoint on the transverse axis. It's that line in the middle, or the dot in the middle of the two vertices. It'd be the midpoint of the two vertices as well. So that's where your center is. These guys here are our asymptotes. If you notice, they're dotted lines that the graph is approaching but not going over. So these graphs will have asymptotes when we graph them. And if I just label on the second one, these guys would be the vertices. This transverse axis would be horizontal, and the center would be right here in the middle where the asymptotes are intersecting. So if you look at this, we're going to have a new rule about what's in control. A squared is still going to tell you what's in control, but a squared will always be the first fraction. So it's the first fraction that's in control for these. It happens to also have the bigger one because if you notice, we have a minus sign now. That's what makes this equation different. It looks very similar to a ellipse equation, but now there's a minus sign instead of a plus sign. So the first fraction will always be the positive one. That's always the one we put first. That one will tell you what's in control. So if you notice in the first equation, the first fraction has x in it, and that's why the hyperbola, the two branches here of the hyperbola, are facing left and right because x is in control. Versus in the second one, our first fraction is y, and the two branches are facing up and down because y is in control. So then there's just some rules here. The transverse axis always lies in the direction of the numerator of the first fraction because again that's what's in control. First fraction's in control. The vertices will be a units away. That's how you'll know where to put the vertices down. They're always going to go with where the first fraction tells you to go. And then the foci are c units away, but we have a new formula for foci, and this is a formula that should look familiar. It's c squared equals a squared plus b squared. So you just need to remember, since this one has a minus in the equation, when we do the foci formula, it's plus, versus with an ellipse, when it's plus in the equation, we do minus to find the foci formula. That's how I have it remembered in my head. And then here is the steps for graphing. We're actually going to make these fancy boxes in the middle to help us to graph them. The fancy boxes are going to lay in the same space that the ellipse would have laid, so that the rules are going to be very similar. But then we're going to draw in these asymptotes through the corner of the ellipse, and that's going to allow us to have the space where the hyperbola has to go. Okay, so let's just practice one. So this first one, the center is 0, 0. There's no h and k right now, so it's just going to start at 0, 0. And then we're going to use the same rules that we used for ellipses. You're going to move the square root of the denominator in the direction of the numerator. You just have to pay attention because now the fractions can flip around. So this one definitely has x on the top of it, which means I'm going to go right and left. And because that's the first fraction, I can put dots down for that first fraction because that's where my vertices are going to go. So I'll determine based on the first fraction. So I went right and left 6. And then the second fraction, if I do the square root of the denominator in the direction of the numerator, that's square root 3. The y is on top, so that tells me I'm going in the y direction 3. I'm going to go up and down 3. But these ones we're not going to put dots down, we're going to put dashes because this is going to help us to start forming our box. So the box has to stay on that line where we put the dash, and then it's going to join up with where we put the dot. And you're going to make this rectangle that goes through the dash and the dot that we laid down. And then we draw in the asymptotes. That's going to be a dotted line that goes through the corner. And then a dotted line this way. When you're in Notability, you can use the straight line feature and make a nice straight line through there. If you want to leave it solid, that's fine. So now we need to look at what's in control. So again, for the hyperbola ones, it's the first fraction that's in control. So I know x is in control, which means this should be facing, the two hyperbolas are going to face left and right. And I know that already because it's where I put the dots down. We're just going to draw two curves that hug against these asymptotes. One on the left and one on the right. But they start where you put those dots down. So then to find the foci, I need to use the formula. The formula for the foci is c squared equals a squared plus b squared. A squared technically is with the first fraction, but because we're adding, it doesn't matter what order you do this in. We get c squared equals 45. And then we're going to take the square root, and c is going to be 3 radical 5. And then same rule for how to decide where to put this. We want to make sure that we are paying attention to what's in control. Since x is in control, that 3 radical 5 is going to go in the x position for the coordinate for the foci. So it's going to be positive 3 radical 5 and negative 3 radical 5, comma 0. And then this part we haven't talked about yet, but if you were to get a decimal approximation for that, that is going to be 6.7 and negative 6.7. So then if we graph that, these should always end up inside of the hyperbola, which means they're actually going past the vertices. So they should be the same distance away from each of the vertices, but they end up on the other side of the box. They should be outside of the box and inside of the hyperbola. Let's try another one. Alright, so this next one, again, we're going to move the square root of the denominator in the direction of the numerator. The center's still at 0, 0. So the square root is 16, but this time, that's 4. Y is there, so that means we're going up and down 4. And the first one always tells me what to put a dot, where to put the dot. So that's going to be a dot. And then if I do the square root of the next denominator, that's going to be 6, but x is on the top, so that tells me I'm going left and right 6. Those are not going to be dots, that's going to be a dash. So first one dot, second one dash, and then you're going to make this box that goes through those points that we've laid down. And then I'm going to go ahead and draw in the whole point of the box, so you can draw in these asymptotes, so you know where we're being confined to when we draw the hyperbola. So try and draw nice straight lines through the corners is what you're aiming for. And then if I pay attention to what's in control, the first fraction tells me that y is in control, which means I know my parabola is supposed to face up and down, which makes sense because look where I put the vertices. These are going to open up much wider because we have more space to get to that asymptote. Again, they need to hug against the asymptote, so you should be drawing them so they get closer and closer and closer without crossing. And then to find the foci, we're going to do the formula c squared equals a squared plus b squared. That's c squared equals 16 plus 36. We get 52 and then take the square root. I'm just going to simplify that down. That's 2 radical 13. And then y was in control, so that's going to end up in the y position so that it will end up on the transverse axis. So it's 0, 2 radical 13 and 0, negative 2 radical 13. And then if I approximate that as a decimal, that's 7.2. So that would be over 0, up 7.2. It's 4, 5, 6, 7, right in there. And 4, 5, 6, 7, right in there. If you notice, because these open up wider, the foci pull farther away. When they're skinnier, the foci are closer to the vertex. So, just something to keep your eyes on. But again, they're inside of the hyperbola, not inside the rectangle. They should always end up inside the hyperbola and outside of the rectangle. Alright, number 3, just like with hyperbolas, we want these to equal 1. So your first step in number 3 is actually to divide everything by 4 here, so that it can equal 1. We get y squared over 4 plus x, or not plus, whoops, minus x squared. I'm going to put that over 1 so I know how far to move, equal to 1. So my center is at 0, 0. That's my starting point. I move the square root of the denominator in the direction of the numerator. So square root of 4. The numerator is y, so that means I'm going to go up and down 2. That's going to be where I put my dot. And then square root of the other denominator is 1. That's just going to be 1. But that means I'm going to be going in the direction of the numerator that's left and right 1. And that's going to be my dash. So this one, we get a teeny tiny rectangle in here, if we can kind of draw that dotted rectangle there. And then the asymptotes are going to come down pretty steep, because this has a steeper slope to it. Much easier to do on paper with a straight edge. But then we need to decide where our hyperbola is going to go. That first fraction has y, so we know y is in control, which means it's facing up and down, which is where we'd put the dots down. So we're going to have a hyperbola up here, and then we're going to have another hyperbola, the other branch of it is down there. And then to find the foci, it's going to be c squared equals a squared plus b squared. It's going to be c squared equals 4 plus 1. C squared equals this 5, so then c is going to be the square root of 5. And y is in control, so that's going to go in the y position 0, comma, square root 5, and 0, comma, negative square root 5. And the square root of 5 is 2 point something. So I know it's just past 2. So these ones, again, if you notice this is skinnier, this ends up pretty close to where the vertices are, but still past outside of the box and inside of the curving hyperbola. It's inside of it. Alright, the last thing we're looking at is how to write equations. We're again going to need to know what's in control. There should be a clue in the problem that's telling you what's in control. And you need to find a squared and b squared to be able to write the equation. So if you're going to answer those two things, it's pretty easy to set up the equation. These ones, remember, because it's the hyperbola, these are going to be minus between the fractions. So we just need to keep that in mind. So number 1 says find the standard form of the equation of hyperbola with a center at the origin. So you know we don't have an h and k right now. And then vertices at 0, comma, negative, plus or minus 3. And foci at 0, comma, plus or minus 5. So based on what we did with ellipses, this should be a little bit easier to catch on to. The fact that those are both going to be going up and down tells me y is in control. And then the foci give me c. So I know c is 5. And the vertices still give me a. So a is 3. We just have to put those into the equation to figure out what b is. So this is going to be c squared equals, use your new equation for today, a squared plus b squared. So it's going to be 25 equals 9 plus b squared. Then we just got to subtract and we get b squared equals 16. And I would know a squared is 9. And now we need to think about what it means for hyperbola problems, that y is in control. That means y has to be the first fraction. So it has to go in the order y squared minus x squared over 1 equals 0. And then a is always going to go with the first fraction. So it's not the bigger number that goes with what's in control. It's always a goes with the first fraction, and the first fraction is going to have the letter that's in control. So 9 is going to end up here. And then the 16 will end up under the x squared. So this right now is your answer. But again, it's the a squared goes with the first fraction, and the first fraction has the letter that's in control. So that's how you partner things up for the hyperbola. All right, number 2 says find the standard form of the equation of hyperbola with a center at the origin, vertices at plus or minus 4, 0, and foci at plus or minus 7, 0. So this one's just slightly different than the last one. For this one, we're noticing that y is in control because those points would move left and right. And I know a equals 4, and I know c equals 7 because the foci give me c, the vertices give me a. I'm going to use my formula right now. C squared equals a squared plus b squared. 49 is equal to 16 plus b squared. And then I'm just going to subtract, and b squared is equal to 33. And then based on what's in control, that tells me what the first fraction has to have. Since x is in control, x is going to be the first fraction. And then a has to go with that first fraction. So a squared would be 16. That's got to go there. The 33 is going to end up over here. And that's going to be your equation for this hyperbola. Alright, just one more. This says find the standard form of the equation of hyperbola with a center at the origin, vertices at 0, plus or minus 6, and asymptotes. This is going to be the new part for this one. Asymptotes at y equals plus or minus 2 over 3x. So let's start with the fact that we know the vertices. The vertices are telling me a couple of things right now. The vertices are telling me that a equals 6, which is important. And because of the positioning of this, they're going to move up and down. That means that y is in control. Alright, what do I do with this asymptote part? Well, the asymptote, they're giving you the equation. What you really want to focus in on is the slope. And slope always comes as y over x. So right now they're telling you y over x is going to end up being 2 over 3. What we can change that to is we can change that by plugging in, since y is in control, I can plug in what they gave me here, that 6. I can plug that in for y, and I know that technically would be a. So then that's going to be 6 over the thing we're missing is b. Is you can just take that fraction, plug in the number they gave you. Since y is in control, we can put the 6 in the y spot. If x were in control, we would put the number they gave us in the x spot. So you just have to pay attention to that. And then we're just cross multiplying and solving. We get 2b equals 18, which means b equals 9. But just be careful with both of these. We want to be able to plug in b squared is 81, a squared is 36, and we know y is in control. So that means that the first fraction has to start with y. So it's going to be y squared minus x squared equal to 1. And then again, the a squared goes first, the b squared goes second. Good? Alright, there is one problem for you to try on Class Kick, and then you have a homework assignment to practice this to make sure you're getting a good handle, because we're going to do another in-class assignment towards the end of the week.